Okay, so hopefully this will help you understanding zeros. So, and what is the deal with them? Okay, they actually can be really confusing in terms of sig figs, and they're really not that bad. You just have to uh, decide. The problem is they can be more than one. So zeros, when you have a zero in your measurement, okay, they can have two different meanings. Okay, one, the zero can actually be a number, right? I mean, it's number. A zero is a number. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 0. Okay, 1, 10. Okay, the 0 and 10 is a number. Okay. The other thing that 0 could be is it determines the power of 10, otherwise known as a placeholder. Okay, so that's the first thing you got to decide, if it's an actual number or is it a placeholder. So whenever you see a 0, you have to decide which one of these it is. If it's an actual number, then it counts as a sig fig, while if it is a placeholder, it will not count as a sig fig. Okay, so what I'm going to show you next is I'm going to show you examples of both of these. Okay, so let's look at some guidelines here. So let's say you're given a decimal number and you want to decide if the number is countable as a sig fig or a placeholder. So a measurement that starts with a 1 through 9 number, the zeros count as sig figs. Okay, so we leave this off here. All right. Okay, so 1.230. So this is our beginning number. Okay, so any number after that counts. All right. So this 0 counts. All right. So this starts with 1. All the numbers count here. All right. This is a 1 number, so that means all these numbers count. So even this 0 at the end. And this number starts with a 1. Okay. So it's so all these numbers count, even these 3 zeros. So this would have 1, 2, 3, 4, 5, 6 sig figs. Okay. All right. Now, if our decimal number doesn't have a 1 through 9 number in it, then you don't start counting until it does. Okay. So, so starting from here, this decimal point, that doesn't count, that doesn't count, that doesn't count. All right. It starts with our 1 through 9 numbers. So start here at the 4. So it's 1, 2, 3, 4. All right. Okay, this number here, well, okay, 0, 0. Okay, so those don't count. They're leading. We call them leading zeros, and these two numbers count. Okay, so kind of think about when you have decimal point numbers, which we use most of the time in our class, is if the first number is a non-zero number, 1 through 9, then every number after it, including that number, is a sig fig. So this would have 4 sig figs. This would have 1, 2, 3, 4. This would have 1, 2, 3, 4, 5, 6, 7, 8, 9. And this would have 1, 2, 3, 4, 5, 6. Okay, down here, okay, these are 0 numbers that lead, so they don't count. And our first non-zero number is 4, so we count from there. So it's 1, 2, 3, 4. Okay, for this number, okay, leading zeros, this don't count and this doesn't count, so this counts as 2. Okay, so decimal points, if you have a non-zero number in front, you count from that number. If you have a 0 in front, you don't count until you get to a non-zero number. Okay, now if you have an integer, and that means any number from with no decimals, okay? Right, no decimal. And we really don't use these too much in science, but sometimes they show up, okay? Yeah, we do use them, but with our measurements these days, we usually have decimal points. But let's look at it. So in this case, if trailing zeros do not count. Okay, so so if you look at the number 200, okay, unless you're given more information, you only, this has a non-zero number, and then these guys don't count. They're just placeholders. All right, so trailing zeros we call them. Okay, so this would only have one sig fig. It doesn't mean the number is 2. It just tells you that within precision or scoring, we are only give it a score of 1. All right. Okay, this number here, it has a 0 ending. Okay, so these first two count. So non-zero numbers count. Okay, for the most part, we'll see that's not the case. But following zeros don't count. All right. Okay. Now, as soon as you put a decimal point in here, if you had 220 point, yeah, then you would count that 0, because what you're doing is you're saying that you think there's a decimal over here. Okay. All right. And therefore this would be your first number, and every number after that would be number. Okay. All right. This number here, this 0 doesn't count, and so it would have 1, 2, 3, 4. All right. Okay. Now this 0 here. Okay, this 0 does count. That's called a trap 0, and it's actually a counting number. This tells like this. So we'll look at the trap zeros here. So this is 20200. These last two zeros don't count. It just tells me how big this number is. It's in the 20,000s. But this 0 here tells me that my number is closer to 2,220 than 2,199 or 20,201. Okay. All right. So or you can look at it as 200. It's closer to 20,200. 100 or 20,300. Okay, that's probably better to look at it. Okay. So trap zeros count. So this would have 1, 2, 3 significant digits. Okay, let's look at this one. All right. We have a decimal number. Okay. But we don't start until we get to a non-zero. So we start here, and every number after it, okay, is 3, 0, 4, 0. So all 4 of those numbers are sig figs. Okay, this number here is a decimal point. It's non-zero. That means all the digits count after it. Okay. All right. So if we go back up here, we see that this number here has a trap 0. So this one counts, but this one doesn't. So this trap zeros always count. Okay. Leading zeros don't count when they're in decimals, and trailing zeros don't count when you have integers. Okay, so leading zeros don't count in decimals as far as sig figs go. Trailing zeros don't count when you have integers, and all trap zeros count. That should be count. Okay, I hope that helps. Let me know if it does. And so okay, one more thing. Let's talk about exponents scientific notation. Let's say you want to change a number to a scientific notation, and so you have to look at the number first, if it's an integer or decimal. So let's look at the two different. So let's say I have a decimal number. All leading zeros in a decimal number will determine the power of 10. Okay, so to write this out, what you do is you're going to count the number of zeros and then add 1, okay, because you're going to start here. So it's going to be this is going to be 3.21. Okay, and then since the first non-zero number starts at the number 5 position, that's its power. Okay, remember it's a negative exponent. Okay, it's okay. So, right now, in terms of integers, all trailing zeros are to help you determine the a power of 10. Okay, so let's say I have a number 22310000. Okay, there are different ways you can do it, but let's first of all just turn it into exponent form, not necessarily scientific notation. Or scientific notation will just have one number left at decimal point, but let's get there in a second. So what I want to do is, so these numbers here, 2231, are counting numbers. Okay, and these numbers here are placeholders. So what you do is we're going to put the placeholders into our exponent. Okay, so this we have, so this is 4 zeros, so it's going to be 2231 times 10 to the 4th. Okay. All right. Now I want to change the scientific notation, so I can just have one decimal left of points. What I'm going to do is I'm going to change this number here. Okay, so that I have just one decimal. So I changed this number here. This number here is 2.231. Okay, times 10. So it's 2,231. Okay, times 10 to the 3rd. All right, and then what you do is you put the 10 to the 4th. And so the scientific notation of this number is 2.231 times 10 to the 7th. Okay, now, okay, so when you see 1, 2, 3, 4, 5, 6, 7, okay, so another way to do it is if you want to change this whole thing without going through this step, you would go start from the right, 1, 2, 3, 4, 5, 6, 7. Okay, so 2.231. You know these numbers here don't count. Okay, so it would be 2.231, and you don't put the zeros on it, but you count it over 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th. Okay. Right, so you can do it either way. Okay. So if you have a decimal, what you do is you count number of digits to the non-zero digits, and that'll be your exponent. Okay, for integers, you can do the same thing. Count from the second non-zero digit. 1, 2, 3, 4, 5, 6, 7. That'll become your exponent. Okay, but when you write the 2.231, make sure you don't include the 0000 because they're placeholders. Okay, so it'll just be 2.231 times 10 to the 7th. Okay, all right. So this only has 4 sig figs, and this number also only has 4 sig figs. Okay, so again, I hope that helps out. Okay, now let's say you want to go changing from scientific notation to a number. Sometimes you need to do this. So let's say you have, so the way to do it is, so you're going to add leading zeros or trailing zeros depending on if you have an integer or a decimal point. Okay, so if you integer, you'll be adding trailing zeros. If you had decimal points, you'll be adding leading zeros. Right. Now to figure out how many zeros you're going to add, it's just simply you take 1 from the exponent, and that'll be how many you add. So let's say I have 2.3 times 10 to the 4th. So the exponent is 4, so I take 1 away from 4, so I add 3 zeros. So it's going to be 2, 3, and then 3 zeros after it. Okay, so and when you look at this number, it has 2 sig figs, and it has the placeholder of 3. All right. Okay, if you have a decimal point, like 5.750 times 10 to the minus 3rd, here the number is 3, okay? So 1 less than that is 2, so I'm going to put 2 zeros in front. Okay, so it's 0.005750. And you can see that this has 4 significant digits. Remember, all zeros after non-zero numbers are significant digits. And here, same thing. Anytime you have anything in exponent form, you're you're gonna assume if it's scientific notation, what you're gonna do is that assume all the numbers in the scientific notation are significant. Okay, even the zeros. All right. So scientific notation, all digits are significant. Every zero. Okay. And that's kind of that's kind of the cool thing about scientific notation. You automatically know how many sig figs you have because it tells you. So I have 2 here, right? Here I have 1, 2, 3, 4. Okay. You can't. So if you're just given 23,000, it's hard to tell how many sig figs there are. So, so it takes practice. All right. So I hope that works.